Everyone, hi everyone. This is subject engineering graphics, and today we are going to see one problem of engineering graphics. My name is Sujit Patil, and I am from Division A, branch Civil Engineering. So this is my PRN number is 2202017, and this is our problem of engineering graphics. So problem consists of a tetrahedron with 100 mm long. 100 mm means we can say it about. Tetrahedron with 100 mm long. This is its length, long edge length is resting on the base on the HP. So considering this is our tetrahedron of 100 mm and it's resting on the HP. So this is the horizontal plane. Consider the table as a horizontal plane and its base is resting on the HP. And we can consider the vertical plane as here is we can imagine a plane which is a vertical. So and next is next data given is it is cut by a sectional plane. So a sectional plane cut that this is a shape, and a sectional plane cutting that shape. Cut by a sectional plane perpendicular to VP and inclined at 45 degree to HP. So it is a cutting that it should be inclined to the HP. So considering this horizontal plane, it is a inclined to the HP. So we can see it, we can consider the pencil as a cutting section. It is a inclined to HP. So next the given is, and cutting axis at a point of 70 mm from the apex. So this is the apex. Apex is the upper point. You can see it also like that. This is the apex. Apex is the upper point. From the upper point 70 mm from the apex. From the 70 mm from the apex here, from 70 mm from apex and 45 degree to the HP, like that. So from that apex, and draw sectional true shape and sectional view. So here is our actual drawing. So first consider this. We have drawn tetrahedron. This is a tetrahedron. Tetrahedron, basically all sides of tetrahedron are equilateral triangles, and there are 1 2 3 and 4. So 1 2 3 4 and 5, considering there are 5 equilateral triangles are there, and one of its base, so base edge is of 100 mm. So this is that. So from here we are going to generate a true shape. So considering the OC is the only length which is the true, as it is the parallel to the reference line. So it is a true, and from here we have projected and we have generated a true shape. This is the true shape of the figure. Now considering the line, this is a 70 mm from the apex. This is the apex point O1, and from 70 mm from the apex, and here is that point, and from here it is cut as the 45 degree. So we can give a name as A, B and C, and this is O. So this is the A dash, B dash, this is the C dash, and considering here as the two sides are there, so it is the A dash and B dash. So here is 2.1 and 3. At the middle there is a no side, since there is a no point, and at last edge there is a last edge or corner there is a point 2 point on the edge CO. So now we have to draw its sectional view. So as the method of drawing of a tetrahedron, so first we can copy this line as it is. So this is the, as this is the true shape, we can copy it as it is, and here it is a copied. So from here we have taking this as a distance in a compass, we can draw a circle. So this is the circle. So of that here we can draw a circle, and now here is our first point, that is point A. Nomenclature are given in the capital letter, and now we have to get its parts. How many parts? 1 2 3. So 1 2 3. So 1 2 3, and then again this point. So we have to convert it into divide it into 3 equal parts. So we have divided, this is the A point, this is the B point, this is the C point, and this is again A point. So here we get that point. For that we use the same length. So base length, how much it is? 100. So using it same as this is the first point, then from here this is the second point, from here it is our third point. So from here we have joined that line, and we get a section for a section, and we have joined those of points by a straight line. We have joined that those point by a straight line, and we get it. So now we have to project the point. The first point we have projected here. This is the first point. Actually there are 2 points on that point, and it is on A and B both. So we have projected that from point here. So we have to project those points on only this true length or a true edge, whatever we have copied here. The second point we have projected is the point 2. So we can see it. This is the second point, and from here we have projected it here. Now by taking a distance of point O to first projecting point on that true shape, we have to draw a semicircle. So we have drawn here semicircle. Then again taking the length of a first projection, that projection point, we have again draw a circle here. Now considering the first circle, the first point is the point number 2, and it is on O and C. So on the edge O and C we have to mark that point. So here we have marked that point. So now considering the first point, it is projected here, and for that whole semicircle we get 2 points. Actually on A there is a 1 point, and on B there is a 3 point. So on A we have marked the point 1 here, and here also A, so 1 point will be here. And on B there is a second point. On B we have marked second point. So we have completed the projection of points. And now as the tetrahedron, it has the edges, not curves. It has the straight or inclined edges, not curves. So we have to join it by a straight line. So we have drawn a straight line and we have joined it. So this is from here to here, and from here to here, like that, and from here to here, and this is our shape. We have joined all of it. So this is our shape, and when we cut this shape we get one part. We can say it the downward part of this trapezium. So this tetrahedron. So this tetrahedron is cutted like 45 degree here, and from 70 mm from the apex. So consider a pencil, and we can get a shape like when we cut it we get it like that. This is our section. So you can see that this is a tetrahedron, and at 70 mm from the apex, this is the 70 mm distance, and from 70 mm from the apex it is cutted at inclination of 45 degree. This is the inclination of 40 degree. And when we open it, so consider that when we open it we see like that. So this is our what we have drawn. So when we open it we can see like that. You can see it. This is the 2 parts. The downward part is the same part as here we see, and upward part, the remaining part, that is upward part, this is the uppermost part. So you can see it's a front view. Front view can be seen like this, and you can also see it's a top view. So on the top view you can able to see the sections. When we opens the section we can get 2 parts like that. So this is all about this problem. Okay, thank you.